functional programming libraries in Scala, that is Cats library. It provides data types and type classes that are commonly used in functional programming, such as monads, functors, and monoids. This lightweight, modular, and easy to use library is a popular choice among Scala developers. So, today we have Humaira and Kuldeepak with us, our mentors for the session, the captains of our flight, who will be taking us through a deep diving session on cats and monads. So, Humaira and Kuldeepak, the stage is all yours now.
Thanks, Pragati, for this wonderful introduction. So, welcome back for this session today. As Pragati has told us that we will be diving through Cats and Monads library in depth. Means we will let you know what it actually is the theoretical part, but also we will let you know with the example. Means the use cases, how we can use that, and what actually is the use case. Since we have a number of rich libraries in Scala already present with us, but still, if we are learning Cats along with monads function. Monoids. So that means there is something which we need to learn about. So yes, we are back. I am Kuldeepak Gupta along with my co-presenter Humaira Ahmed. We are software consultant in Nodus INC. Humaira, we can proceed.
Thanks for the introduction, Kuldeepak. All right, so let's look at the basic knowledge etiquettes. First one is punctuality. To join the session, 5 minutes prior to the session start time. Then do leave a constructive feedback for us to improve on. And then keep your mobile phones on silent and feel free to move out of the session in case you need to attend an urgent call. And kindly avoid the disturbance, unwanted chit chat, and to unmute yourselves only if you have some queries. All right, let's look at our agenda. So the first one is going to be the introduction to Scala Cats. Then we'll move forward with type class components. Then we'll look what semi-groups, monoids are. And then finally, we'll be like diving deep into monads. All right, without further ado, let's say introduction to Scala Cats. All right. Basically, Scala Cats is a library that provides the abstraction for functional programming in Scala. Its goal is to provide the foundation for an ecosystem of pure typeful libraries to support functional programming in Scala applications. Obviously, we'll be seeing a whole lot of examples as we move ahead. The name is a playful shortening of the term category from the category theory in mathematics. Let's see some of the features of cats. The first one is it's fast. It provides lightweight fibers for asynchronous high concurrent applications. It keeps your application up and running under the high resource contention. It provides a thriving ecosystem of streaming frameworks, database layers, HTTP servers, and much more. Also it has a community. That is OS software maintained by type level community. Now let's move ahead with type class components. Kuldeepak, would you like to take over?
Yes, please. Okay. So when it comes to type class components, Cats library contains a large variety of tools for functional programming. When it comes to functional programming, it has it not ever only large variety such a I need to say it has a rich variety of tools for functional programming, and it delivers these majorly in the form of type classes. So what actually is type classes will be served in three forms. I will let you know along with the examples as well. And one more thing which I want to tell you that these type classes we can apply these to the existing Scala types as well. So it starts with type class. Can we go to the type class first? Yes. So as I think everyone who is aware of the programming language, which is Haskell, we known to what actually is a type class. So type classes are a pattern in programming originating in Haskell. The main intent, the main aim is to extend the existing libraries with new functionality. Since if we are not able to change the existing libraries, what we need to do, so we can extend them with new functionality. Also, we don't need to use traditional inheritance, which is typically a boring system for us. So what we don't need to use the traditional inheritance also without altering the original library source. What we have to do, we have to extend that existing library with our current program. So this is all about the type classes. And also API represented by traits means when it comes to type class, you have an API which is represented by a trait. I think everyone is aware of the trait in Scala with at least one type parameter. So Cats tries to provide a single generic implementation for every type and pull out the necessary pieces into a trait. So this is all about the type classes. And when second one is the type class instances. So once you have the trait with you, you have some methods with at least one type parameter. So somehow you have to, define the body of that method. So for the same, we have type class instances, which is used to provide an implementation of the type class for a specific type. Again, I'm repeating my words. When it comes to type class instances, it should be type specific. Means when it comes to integer, the method should only be applicable to integer. When it comes to string, it should be applicable to string only. Instances, which are defined by creating concrete implementation of the type class and tagging them with the implicit keywords. So here, one thing which we need to learn about is when every time when you are we are using the type class instances, you should use the implicit keywords as well. And these instances are also known as implicit values, since we will be using implicit keyword over there to instantiate those values. Member of the type classes are usually singleton objects. This is one thing which you need to learn about. Can we move over to the use of single type? Yes. So now we have type class use. So what does this mean actually? We have to, means when it comes, you have trait with you, you have define the body of that trait. Now how you can, the last thing which you have to do is you have to expose those methods to the user. This is the main and third part, and actually the final part of your type classes. So you have two ways. First way, which is the simplest way, you can create an interface that uses the type class, and means you can create all the stuff and you just need to put them into a singleton object, and through that singleton object you can access all those methods. So for that purpose you have to use the object and just import all the class instances which you want to use. So the first way is using the singleton object. And alternative to the singleton object, which is actually is your second way, you can use extension methods to extend existing type with interface methods. I think we already have some sessions about Scala 3 where we have a new functionality where we can extend the existing method. So you can use those extension methods, and for that purpose you have to use syntax, import it along all the set instances for the types needed. So this was all the basic which you need to learn about the type classes when it comes to Scala Cats. Now how Scala Cats provide those rich functionalities into the code itself. Let's go to the demonstration part and learn how actually is the real implementation, how we can use it in a short way. So can we go to the demonstration, please? Okay, so we have type class components here where we will be having a number of classes representing each functionality. So let's start with the type class first, which is in the formatter itself. So as the definition suggests you that it's just a trait which have method with at least one type parameter. So what I'm trying to do is I'm just creating a formatter which accept a type T, means it might be string, it might be integer, it might be anything which you want to. And what I'm trying to do is I'm just trying to create a method which is format, which actually, just say for example, it is analogous to method which is known to be toString. I think everyone is using a toString method. So I will let you know what actually is the disadvantage, the drawback of toString method. And we will try to, come over that drawback as well. So we are trying to make a method which is format, which accept a type parameter, which is type T, and we will be returning a string. So let's try to define the body of that formatter now. So let's go to the formatter instance now. Yes, let's go to the formatter instance, which actually extends, which actually have the definition of formatter. So we are trying. This is an object, as I told you that for when it comes to instancing, means when it comes to instances, you can create a singleton object and you can define all the bodies over there. And one thing which I told you that it should be type specific. So for every type, for possible type, which I do know for now, I'm just trying to create for that purpose. So for example, for the purpose of a string, I'm trying to create an instance for formatter, and I'm just redefining, means I'm overriding the value the format method, and means actually I'm giving the body according to my needs. So what I'm trying to do is I'm accepting an integer and I'm returning a string, that converting into string and then the value. This is the value of the body of the format, and this is, and I'm also using the implicit val as I told you, and this is for the integer, and for the purpose of a string and for the purpose of list you can define a number of instances as per your needs. So for now I'm just using int, string, and list of any. So this was the second step which I told you, which you need to learn about for the instances. Now the third step, which is the formatter interface, where you need to expose the method to the user. So what I'm trying to do is I'm trying to create a method display which is which will be analogous to the print ln, means which will be helpful to print the values to the console. So what I'm trying to do is I'm just accepting a parameter, means parameter of type t, which might be anything again, and I'm just putting some implicit, since it's when it comes to type class, it's all about the implicits. That's why I'm using implicit keyword everywhere. So this will be the first approach, which I told you that you can just expose it into a singleton object directly for the user. So this is the first way. I'm just creating a display method, and I'm just having an implicit formatter, which will be of formatter type, which was the first step for me, and I'm just returning a type unit. So this is the first time, and second one is using an implicit class. So what I can do is I can create an implicit class which named with display syntax accepting of type t, and again the method will be same, the definitions will be same to how to print this value to the console. So these are the three steps which you should learn about when it comes to type classes. And don't worry, these are for now, but when it comes to cats, they will provide you by themselves. I will show you later on. So let's go to the implementation, means how we can call all those three parts at a time. So let's go to the application class. So this is a singleton object, which is the entry point to your program. So what I'm trying to do is I'm just trying to print my values in both the ways, since I declare, means the I use the two ways to expose the methods to the user. First one is using the implicit class, and second one is directly. So the first two lines, which is line number 8, line number 9, which is I'm just using the method display along with two parameters. First one is of 45 and second one is of 789. So let's try to run this program in a very short and see what actually is the output, since we have modified our string. So it should reflect here. See, for the let's see for the second part first, which is the integer 789. So I told you that we have put a logger that we will be getting a message converting into string, and then the string, which is 17. And for the string, we were just using some special symbols to show that yes, the string is here and we can recognize that our program is working. So this is the implementation behind the scenes. Now I don't want to attempt these methods again and again. I just wanted I do have these methods with me. So Scala Cats provides these methods with you. So let's go to that show. Let's go to the Cats show first. So as I told you that we don't need to create those traits, those instances. Scala or Cats already provide us those methods. So that method's known to be the show. If you want to look around in build.sbt, we have provided two types of libraries as well, means two types of dependency. First one is for cat score, which we are using for now, and later on for the demo we are using cats effect as well, which will for that purpose we will be using IO, and shortly we will let you know what actually these things are. So go to the cats show first. So we have created three instances. First one is for int, second one is for string, third one is for list of double. I think if you go to the means this show method is just analogous, for which we have created the formatter instance and formatter interface. So this is just the analogous. Now one will ask me that if I can use .to string, then why we are using show? The main answer and the important aspect which you should learn about is these show methods are types. If say for example, if a single method is almost used for everything, means if you want to print a case class .to string, if you want to convert the integer .to string, that's not good. One method should do only one thing. So that's why this show method is a really type safe method. So what we are trying to do is we are trying to create three instances. First one is for int, second one is for string, and third one is for obviously list of double. So what we are trying to do, we are just using those methods to print the values to the console, just like println, just the normal method to print any value to the console. Then we are trying to do is a print string dot show. Show is the method which the small show is method inside the show library. So this will be this will print yes to the console, and again for the list for 94, it will also print the symbol to the console, and same for the try or new. Now these are the normal things, means we can see that we have instances, we have instantiated the classes, and that's why we are using. Now what about the fourth one, which you can see on the screen, is println 34.show. This is the effect of implicit. As I told you that we may have some implicit classes as well. That's why we can use those methods directly even without instantiating them. So this is that implicit class method which you are using to show the 34 on the screen. And if you go to the imports, can we go to the imports, please? You can see that we have already, imported everything on the console. See, we have cats.show and we also have cats.implicits.toShow. This was the same method which we are using to print 34 on the screen. So this is the first part which you can use when it comes to cats. Means this is just an introduction to how to use cats into your program. Let's have a broader way. Can we go to the cats show 2 now? Now let's take a generic example to elaborate how actually we can use cats in our program. So let's say we have a case class which is known to be info, and this have two parameters with it. First one is name, which is of type string. Second one is age, which is of type integer. Now what I have to do, I have to apply those cats principle into on this case class as well. So what we can do is, first we have to instantiate for info. So what we can do is, we can just implicit val, then new show, and then what I want to do is, I want, as I told you, that show has a method show, and we want to refactor that method. I want that, I don't want to print those values in that format. I do have my own format with me. So what you can do is, you can, if you want to refactor that method, you can extend it as I told you. So what you can do is, you just need to implement that method again using override def, and you can implement that show method again, which will be returning a string again. So what I'm trying to do is, I am just sending a string which is info received, then info name, then info age. So this is the second part according to the type classes. Then again, for the so this is how you can print the values to the console. The second thing is, you can using a show syntax, which is I told you that the second way to expose the methods to the user, through which you can use an implicit class. Then again, the method should be same if you want to keep it a high generic. So this is the second way. So this is the first one is the first way is again where you can directly expose the method to the user through an singleton object, and second one is using the implicit class. So this was an overview of how the cats are working in Scala and what are their uses when it comes to type safe, and the implementation behind the scenes, means under the hood, how these things are working, especially the show method, which I have told you in this code. So this was all about the type class components. We can proceed, Umera.
Oh, sure. Thanks, Kuldeepak. Okay, so let's just continue. All right, so the next topic is semi-groups. Let's just see what semi-groups are. So in mathematical terms, it's an algebraic structure consisting of a set together with an associative binary operation. In general terms, or in simple language, it's a generic type with a binary operation and satisfying associativity. Let's just see how we can define a semi-group. So it's basically a trait having a type argument, that is over here. It is pretty much a glorified combined function. So this is a trait with a combined method that takes two elements of type t, and it is going to return this t. Imagine semi-group as a semi-group of integer where we can combine the method, and it basically multiplies the two integers, right? So semi-group can be used in a very general way in order to combine various elements of the same type. It's useful when you want to design a very general API where you can combine elements that you have no idea. But if you have semi-groups in scope, then you can call the combine method and get the result. So that is just the overview of semi-groups. Now let's move forward and see what monoids are. So again, first the mathematical definition, and that is it's an algebraic structure with a single associative binary operation and an identity element. Let's make it easier. It allows us to add or combine values, working with lists, adding values, or concatenating strings. The other example, like of a monoid, it's again a trait. It's just the extension of semi-group as it extends semi-group. We can see over here. And like Monoid basically is an extension of semigroup, and beside the combine method, monoid also has a method that defines a neutral element for that operation, which is present over here, and that is called empty. So it is a neutral element for the operation function, such that if you combine any element with empty, you'll get the same element in return. So think of it as multiplying anything with one. That will result in that particular element itself. These are the, I would say, the two easiest type classes in cats that we have. Um, Now let's see what monads is. Obviously, we are going to dive deep into monads. So let's first look at some of the definitions. It's just a common abstraction in Scala, an abstraction that allows us to represent sequences of operations within the context, such as list, options, futures, try, etc. The definition of monad is it's a trait, and it is having the two methods. Will be like seeing this via code itself. I'll take you directly to the code and see what we have. All right. So before going to monads, I'd first like to discuss the functors. Now let's see a higher kind of type classes. So the functors are the higher kind of type classes that we have. A functor type class denotes a capability of mapping the wrapped values. Right, so the trait functor takes the higher kind of value, that is f, which is again it's generic, right? And the func type class has parameters a and b. The parameter fa, which is of f of a, and a function that will turn a into b. It's over here, and the end result is going to be f of b. So why do we exactly need functors? We need functors type class for the capability of mapping things in a very general way. If we want to make if we want to abstract away many APIs that looks the same, we use functors. So let's take an example of a functor. Let's say we have a list over here, list two times. And it's taking the parameter as list of list of int, and it returns list of int. So it's the implementation over here. Let's say if we were to make an API, so if we are using list, then we would have to like create this method. For options, we would again have to like create another method. That's where like functors comes into picture, where you can like use the general API that is general two times. Now it will look something like this. It should be applicable to any wrapper type that has the map function. This general two times will take a type of f, which is generic. Like list, option, anything we can use over here. Instead of passing list or option, we'll pass a keeper of type f of int over here. This will result in f of int. Now, in order to provide the mapping functionality, we need to provide f of generic type with the capability of mapping over the internal values. So we provide an implicit for a functor over here, which is of type functor of f, and if we have this functor in scope, we can easily call its map function, right? So we can call for example this functor dot map inside the keeper, and then we like do this two times. So what this will do, this is a very generic sort of method that we can use, and like within this general two times, we can now eliminate the above two specific methods. For example, this list and options, we can eliminate these and just use this simple method over here. All right, so let's see how cat makes things easier for us, right? If we have this, okay, so I should just uncomment these, right? So if we have this import, we can see the use of functors using the cat library. However, we are seeing this thing in red right now. And that is because it's using the type of functor f, which is the trait I've defined over here. But if I comment this thing out, so we'll see it starts working. Right. So here we can see we can directly use keeper.map. That's the beauty of it. We can use keeper.map, and then we can do underscore 2 times of it. This is the like very basic example of how we can use cats. Um, all right, so cats created these type classes for us to be able to provide some functionality to our very general data structures. Now moving on to the next trait, and that is the applicative trait, which extends functors. Okay, so it contains a method called pure, which takes a type parameter a and takes a value of type a, and in turn, this type a into a type wrapper of f of a. Now, isolate the fundamental behavior of functor, as Kuldeepak already told, that it is having a behavior like one behavior, which is the ability to map. Applicative have one method, which is the ability to lift a small value into a wrapped value. So most type classes in cats isolate the independent behavior. Now the next is going to be the trait monad, that we obviously are going to see like few more examples of monad. But monad basically is a trait, and it takes the type parameter of f, which is itself generic and extends the applicative, that is the trait over here. It extends the applicative of f. The fundamental method of monads are pure and flat map. Obviously, it gets pure from applicative itself, and then it is having the method flat map over here. And now the flat map, and we like already know that flat map is used for lists, options, etc. We also get a map method, as monad extends applicative, and which in turn extends the functors. So that's where maps comes into picture, and we can also use maps with monads. Now I would like to pass it on to Kuldeepak to see some of the high level examples of monads.
Thanks, Humera. As we have seen how beautifully the Humera has explained about the functions and monads. So let's have a use cases how we can implement monads into our program. So what we are trying to do, we are just trying to make a scenario where we have to store some values into the database. And I believe everyone has aware of the fact that we are using future in our Scala program. So, but there are some side effects with the future. That's why we are using another fact from cats, which is known to be the IO, which is just analogous to future. So uh, let's start creating a use case. So let's go to the db first, which is again a trait where we are just trying to make a method which is used to store the user again as a case class, where we do have some values in case class. And what I'm trying to do is, we instead of returning some string with the future, what we are trying to do is we are just returning a string from with the IO. So we will see how the IO is pretty different from the future. Also, I will also explain those facts with you. If we have some trait, that means we have to instantiate all those methods. We have to define the body of the methods as well. So let's go to the dvimpl, which is, this is the same structure which we are following in our projects as well. So what we are trying to do, we have created a dvimpl, which again is extending a dv, a trait. So in that case, we have to override the method store. So what we are trying to do is, means for now, if we don't have connected the code with the database, because the main thing which we need to look around is how we can use the IO, which is analogous to the future. So what we are trying to do is we are just returning a random value which is known to be the ID to the user whenever we are storing the user. So we are returning that string along with with IO. So just like future, we have two methods. First one is future.successful, future.field. Same here, we are using io.pure, which is just analogous to future.successful. So what we are trying to do, we are just trying to return a value in the form of io.pure, and then we are just returning a random value to the console. Now from where we are using it. So let's go to the monads 2. Okay, so monads 2 is again an an entry point to our program where we can run our the entire code itself. So first one is the user which I was talking about. So we have created a case class user. So this case class user is actually having only one parameter, name, which is a type string. So I think many of us has used user, but a very few of us has used the methods over there. So I'm using a method assert along, means where I'm just defining some constraint that the name should not be equals to null and the size of name should be greater than 4. So this is the condition for which I will be accepting the name in the case class user. So let's hold this part for now, because this is something which everyone knows about it. But before going too deeper into the monads, we need to create a small small example how actually the monad is. Only then we will be able to use some operations over the monads. So let's go to the monads first now. So this is a very simple, very generic, and everyone is already using those functions into their projects or into their accounts as well. So I'm just having two examples elaborating that all the scenarios along of the monads, how we are using and what actually it is. So I do have a case class which is accounts, which is a type generic. It might be string, it might be anything, and there I've defined two methods. First one is extract, second one is bind. As Umer told you that for monad we should have two methods. First one is unit, second one is flat map. Extract is just unit, and bind is just flat map. So what we are trying to do is let's create a scenario where we have some external API, which is and we have to use that API, means we have to use some methods from API, and that method is just the above one, which is process account. And what actually it is doing, it is accepting a variable of type A and just returning an account with a type A. So it's just the same, this is nothing else. So this is the external API. Now what actually is the problem with this? We have to do something that if whenever we are passing a string, if we are passing let's say we are passing an integer to that process method, process account method, since it's an external API, we can't do anything. What we can do is we can extend that API in our program and can define our own functionalities. This is the first thing which we told about in the starting of session. So what we can do is we can create another method, bind. Now what is the use of bind here? Let's put bind method apart from the session. Let's first think how we can do this. Means if I'm passing a number to the process account and we have to check, means what we have to do, we want the process account to multiply my number by 2. So what we can do is first we have to pass the value as 34, means I'm taking a value 34 for now, and we have to pass that value to the process account, which is our external API, and that account will return me a value. So the second step, what we will be using an extract method, and in that extract method I'm using a method which is synchronized, which is again from the cats. Okay, so what I'm trying to do is I'm just extracting the value. So from the process account we have get the value which is 34, which is of type int. So the second step is complete, and the third step is we are trying to multiply our value by 2, and then I'm just returning the value of type account along with the value. So this is the traditional way, means you have extracted, you have transformed, and you have just returned the value. So this is the traditional way, but this is not the good. I want something else, means we don't want to waste 4 lines of code just to do a simple thing. I want to do that all the stuff in a single line in a very similar way. So what we can do is we are just creating our own method, which is def bind, or you can say a flat map or map method for you, which is accepting type A, and just it is accomplishing it to the account with type B. And what it is doing, it is just processing means our number along with the functions which we want to. Say for example, I don't want to multiply my number by 2, I just want to multiply by 3. So it's just accepting that function for which you want to on which you want to perform your operation. So what we have to do, we have to just use that method bind along with the operations what we want to do. So what we are trying to do, we are just using that processed account, and then I'm using my method on bind, and the value which we have extracted from there, I'm just using that value to pass it onto the account. So this is how pretty simple you can use monads for your purpose. So this is the basic example from which you can come out to then traditional approach to a modern approach of using monads. So this is the basic fundamental. Let's create another scenario. And what we are trying to do, we have a case class again knowledge, for which we have two parameters. First one is topic, second one is presenter, and both the parameters of type string. So what is the constraint with us? Since it is a knowledge, so the topic could not be null and the presenter could not be null. So we have defined our assertions that the topic could not be null and presenter could not be null. So what if someone passes a null value? So you have a traditional way, which has been defined in the first function, which is def start knowledge. What we are trying to do, we are using a traditional approach using nested loops, that if topics not equals to null, then this, else this. If topic is not equals to null, then we have to look for presenter as well, or we can do a simple step that topic is not equals to null and presenter not equals to null, then return knowledge and then or null. But this is not the good way. You are not supposed to use nested loop unless it is a need. So we should have approach towards the next step. So what we are trying to do, we are using for comprehension. For that purpose, what is in my mind, that instead of returning a knowledge directly, I'm just trying to return an option of knowledge. What if I do have some topic as null? In that case, I won't be able to return knowledge. Right? So instead of returning knowledge, I'm trying to return option of knowledge. So what it will do, so for that purpose, we are using for comprehension, and I think everyone is using for comprehension in their program. So what I'm trying to do is, I am just wrapping up my topic and presenter into an optional value, and then returning knowledge of end topic and end presenter, which is pretty simple for everyone, right? Another step is of using flat map. As I told you, that flat map is one of the basic part of the monad. So where you can using flat map. So what you can do is, you can use optional topic and optional presenter again, and you can just do a flat map operation over there. Once you have extracted some value from topic and presenter optional values, and then you can use those values to return that option of knowledge. So this is how the basics of monads is, and how easily you can use. And I think most of us will be using in our daily program. So this is the basics of monads, and let's use this concept in our use case as well. So let's go to the monads 2 again. So as I have elaborated, the first step means how you can use the monads. So now let's concatenate the monads along with the cats effect. Since the session is all about using creating a use case where you will be using monads along with the cats. So the first thing which I have to do is, I have to make sure that my program is highly type safe. For that purpose, I'm using two implicits. First one is for again the user, for which I'm using a method show, which will be returning a string in my own format. And second one, since when persisting my data into the database, what I have to do, I will be returning a string. So for that purpose, I also need to create an implicit as well. So for that purpose, I'm just creating a variable, implicit variable, which is known to be the show ID, and that will be also in that case. I'm just overriding the same method, creating my own string that will be processed user with ID. So this is the basic two-step, means in which I have created my own types. Now let's do something. So the first one is getting the values from, means storing the values to the DB. So first you have to instantiate the class. So I've instantiated that class using in DB IMPL. So now I'm able to access all the methods which has been present in DB IMPL. And the second one is, I'm just trying to store a user to the database. So I'm just trying to use a db.store user and the king class along with the values. Since the size of null is greater than 4, it means I'm able to store my value and it's not equals to null. So in that case, I will be able to store the value into the database. And again, for the as we are getting some ID with IO, so we have data type as io.string. So we are just doing some map over that and just printing the value to the console. So this is the basic use case where you can use the cats along with the monads in your program. So this is the basic session for that purpose. In the upcoming session, we will be giving you a use cases for how we can apply cats and monads in our program at a high scale. So this was all about the session. But one question which will be in everyone's mind is, what is the difference between future and IO? We can use future, then what is the need of IO? Because future is almost fulfilling every of our need. Then what is the need of IO? So we can compare future and IO on three aspects. First one is actions. When it comes to the action, IO is a value that describes an action. But for the future is a handle to the result of an already running action. So future and IOs differs on the action. Second one comes to the speed. future is optimized for fairness, but when it comes to throughput, you cannot beat the IO. So IO is optimized for throughput. Third point on which I can talk about is, once you have created a thread, then how, if are you able to handle that thread? We can do that in the case of IO. So the third point on which the future and IO differs is the cancellation. For the future can't be cancelled once constructed, and it can't be stopped. Means you are just wasting your resources, right? Means when you created a thread, you can't control them. You just have to wait until it completed. That means you're just wasting your resources. But when it comes to IO can be concurrently forked, then either joined or cancelled. Means there are high level construct around this in Cats effect. So this is all about where IO is a step ahead of the future. So that's why we are using monads with the IO, means in this session. So this was all about the cats along with monads. Humera, we can proceed to last.
Uh, sure, Kuldeepak. So, yeah, that was it, guys. Do you have any questions? Anybody?
Thank you so much, Humaira and Kuldeepak, for this wonderful session. There are a lot of key takeaways from this session, like type class instances and how we can use them. We also learned about semi-groups, followed by a brief on monads, monoids, and functors. And also, to conclude, Kuldeepak said about futures and IO and its difference. So yeah, it was really an informative session, guys. Thanks a lot. We are now open for any kind of questions or queries, as well as some feedbacks, if any. A feedbacks helps a presenter to improve themselves. So now we are open on that part. Thank you so much, Kuldeepak and Humaira, once again for this wonderful session. If anybody has any kind of queries, you can always reach out to them. Thanks everyone for joining the session. See you soon in the next one.
Thank you, Kuldeepak and Humira, for such a wonderful session. So, in case if no one has any questions, so I'll end the meeting for everyone. Okay.
Sure. Thank you.
Thank you. Thank you.
Thanks, everyone.